Okay, so for phenotype, it's pretty easy. So basically, if you look at it, this is going to be the phenotype ratio. So 4 is the dominant, and 0 is the recessive. So if you look at here, you will see that there are no lowercase letters. Whereas if you have like two W's, so like white and then like white spots or something for the lowercase, then you will have, for all of them, capital W, lowercase w. Sorry, my paper keeps on falling. So basically, dominant is, it's going to be the capital letter, whereas recessive is the lowercase letter. So if you look at it and you have the multiple, so like I had said before, you can have the, like this one, if you had different letters, this one would be like the capital, both capital, this one would be capital, lowercase, and this one would be lowercase, lowercase. It goes off the very first letter that you have in the Punnett square. And the like with the two letters, it goes off the first one. So for that, you would basically go and say 4 for the dominant in this case, because there's only 4, there's capital letters. Whereas lowercase, there's none. But if you had it like capital, 2 capital, and then there's a lowercase, and then lowercase, lowercase, you would have to say 3, 1. And if you have others, like, it's pretty simple. See? Okay, so codominance. Codominance is when you breed two parents and you can definitely see that they're both parents in the baby. So for an example, if you were to breed a black cat, the white cat, you would definitely, like, you would get a black and white cat. You would definitely be able to see that there's both parents in the baby. Whereas for incomplete dominance is when you breed like a white cat and a brown cat and you get orange. Like, you don't see either of them at all. So it's basically codominance is when you can see it, and then incomplete is incomplete. Like, you can't, incompletely different. You can't see it at all. Okay, so mutations. They can be both good and bad. A mutation is a change in the structure of a gene that it basically impacts the different parts of the animal. So like it can impact the way that they have like their muscles like rearranged, like in cows, well, in beef. Basically, it's how some have more muscle in the back and then some have more muscle in the front. So that could be a mutation. Or for sheep, there's a thing called beautiful buttocks. And the trait was first born in Oklahoma in 1983. It gives sheep huge butts. And basically, by understanding how it works, they could help farmers raise meatier and more leaner sheep for meat, because it happens. But for beef cattle, there's a thing called dwarfism, and it's an inherited defect in many breeds of cattle. So basically, calves are born with a deformity in like the head, the spine, or other limbs, and they can have shorter legs. So basically, it makes them smaller than they should be. And next, sex-limited genes. So an easy way to think of it is genes that are limited by sex. So an example is like for chickens, roosters, like you can definitely tell that it's a rooster and a chicken, like, well, a hen. So a rooster, it has a thing on the back of its foot called a spur, and they use it like for fighting. I'm pretty sure they use it when, like, if there's a predator that comes, they try to sneak up on it and they attack. And you can tell it's a rooster a lot of times because they have the longer, more colorful tails. And then in rabbits, doe, which is a female rabbit, they have a little like flap of skin called a dewlap underneath their neck. And it's basically extra skin to grow fur on so that when they have babies, they pull the fur out and they use it in their nests. So that's basically sex-limited genes. Like, you can tell, it's basically there's different traits in animals that only females have or only males have, that it's sex-limited genes. So